In this video, we're going to use the fundamental theorem of calculus to find the derivative of an integral function. It says, given f of x below, find f prime of x, and they give you f of x is equal to the integral from 5 to x of 3t to the 6th minus 2t to the 4th plus 4 dt. First thing I want to do is write down what the fundamental theorem of calculus is. It says that f of x, or capital F of x, is equal to the integral from a to x of f of t dt. So if this is true, and the function inside here, f of t, is continuous, then we can say that f prime of x is actually equal to f of x over the interval, so I'm just going to say over the interval a to b. And I think that this formula can be a little bit, or this fundamental theorem can be a little confusing. So I want to show you how we're going to apply this, because see, we have f of t in here, f of t dt as our function, and all of a sudden they're saying, okay, f prime of x is equal to f of x. And you're like, well, what the heck? We went from variable t to variable x. And it has to do with this piece right here. And the a is going to make basically, it's going to make the second piece of this integral, it would make it a constant. So we're going to show that here. I'm just going to show you some algebra on this. So if I were to take the derivative of the left side, I end up with f prime of x is equal to, and I do the derivative on the right side. So I just say d over dx of the integral. I'm going to kind of put this in, I don't know, parentheses here. So put some parentheses here. The integral 5 to x of 3t to the 6th minus 2t to the 4th plus 4. And then dt. So we're going to take the integral of this right side to start. So we're going to say that this is f prime of x is equal to, when I do the integration on this, I have to find the antiderivative. So I'm going to be adding 1 to the power and then dividing by that power. So I'm going to end up with 3. So d over dx of this whole thing, I'd end up with 3t to the 7th divided by 7 minus 2t to the 5th divided by 5, and then plus 4t to the 1st divided by 1. And then I'd be evaluating this from 5 to x. So then I can go through and say that, all right, this is f prime of x is equal to, when I go through and evaluate with x and with 5, I end up with the derivative still. I haven't taken the derivative yet. Of, that would be 3 times x to the 7th over 7 minus 2 times x to the 5th over 5 plus, this would just be 4 times x, and then minus, and I'll have 3 times 5 to the 7th over 7 minus 2 times 5 to the 5th over 5 plus 4 times 5. And so now, and I should probably put parentheses on this piece. So now I'm going to actually take this derivative and use the laws of derivatives to split this d over dx between these two pieces. So I'm going to say that this is really d over dx of 3 x to the 7th over 7 minus 2 x to the 5th over 5 plus 4x minus the derivative of, this would be 3 times 5 to the 7th over 7 minus 2 times 5 to the 5th over 5 plus 4 times 5. So then you can see that when I take the derivative of this last term right here, this is all a constant. So derivative of a constant is 0. So I'm going to just have minus 0 here. When I take the derivative of this piece, 7 comes to the front, so I end up with 7 times 3 to the 7th, 7 times 3 sevenths, x to the, and I subtract 1 from that power, so it's x to the 6th, minus, bring the 5 to the front, I get 5 times 2 fifths. This would be x to the 5th. And when I take the derivative of 4x, I just end up with 4. So now f prime of x is equal to, if I multiply these two fractions, I cancel the 7, so I end up with 3x to the 6th minus the 5's cancel, I get 2x to the 5th plus 4. Well, remember, our original function here was f of t, right? It was 3x to the 6th minus 2x to the 3t to the 6th minus 2t to the 4th plus 4. Well, I have the exact same function here. Oh, I forgot to subtract 1 from the power. All right, bring the 5 to the front and then subtract 1 from the power. But I have the exact same function written right here, but instead of a t variable, I have the x variable. So this is actually equal to f of x. So that means that f prime of x is equal to f of x. So we go back to the fundamental theorem of calculus. We saw that we had f of x equals the integral from a to x of f of t dt, and that f of t is continuous, it's a polynomial. So we know right away that f prime of x, so the derivative of this, is equal to just f of x because of this upper limit or upper bound on the integral. And I could have just went right away and said, okay, so f prime of x, derivative of this, is just going to equal 3x to the 6th minus 2x to the 4th plus 4, instead of doing all this work. And so that's kind of what's nice about that fundamental theorem of calculus, is tying together integration and differentiation and saying basically that they are opposites of each other. So I'm probably not going to go through this whole piece again like this, but this is nice to show that, yeah, f prime of x will equal f of x when my upper bound is a value of x.